Near duplicates pollute search results long before you notice recall problems. I'll use Shingles and Jaccard Similarity in Python to catch overlap early, so you can clean an index before duplicate pages crowd the top results. This is the setup you'll be able to run after this, which builds shingles and flags near duplicate documents using overlap scores and a threshold. I'm Professor Pi, teaching search and IR with simple Python. Near duplicate detection is one of those toolbox items every search engineer uses. You land duplicates in search, recommendations, or analytics. They bias metrics and waste user time. Jaccard Similarity and Shingling are a cheap, interpretable way to spot overlap without heavy models or embedding stores. Success is when you flag obvious near duplicates early, so your index and metrics stay cleaner. Think of Jaccard as a fraction. It measures shared pieces over all pieces combined. Shingling turns a text into small contiguous phrases instead of single words. Together they answer this question: how much of the phrase inventory is shared between two pages? If the overlap is high, the pages are probably near duplicates. At a glance, you get a pipelines that tokenizes text, makes shingles of length k, computes intersection over union, and filters by a threshold t. Strengths are simplicity and speed on small to medium corpora. Weaknesses are sensitivity to small edits and a need to tune k and t. That trade-off is useful. Longer shingles are stricter. Shorter ones are looser. We will build a tiny end-to-end toy that shows 3 documents, tokenizes them, computes word set Jaccard, then computes 3-word shingles, ranks pairs, experiments with k, and finally uses a threshold to filter duplicates. This keeps the code parts focused and the results easy to interpret before you scale it up. Now we start by showing the simplest overlap: word sets. This snippet computes Jaccard similarity between 2 documents using word sets. The dictionary docs holds 3 short texts keyed by simple IDs for easy reference. The function talk lowercases each text and extracts alphabetic tokens with a compact regular expression, giving clean word lists. The function Jaccard converts those lists to sets, then divides the size of the intersection by the size of the union, yielding an overlap score between 0 and 1. Finally, it computes the score for documents A and B and rounds to 2 decimals for a readable display. The printed value shows how much raw vocabulary the 2 texts share, an initial signal for near duplicates. Next, we tighten matching by grouping words into small phrases. This example builds 3-word shingles and measures a stricter Jaccard overlap. The function shingles uses the earlier tokenizer to form contiguous triplets of words, capturing local phrase structure rather than isolated terms. The helper Jaccard sets computes the intersection over union for 2 shingle sets, just like before, but now on sequences. We create shingle sets for documents A and B with k set to 3, and compute their similarity. Because phrase order must match for shingles to overlap, the score usually drops relative to word sets, filtering superficial matches. Increasing k demands longer exact matches and lowers similarity. Decreasing k relaxes matching and raises similarity. Now, we look across the whole small corpus to find the top near duplicate pair. This code scans all document pairs and reports the most similar under 3-word shingles. It first builds a mapping S from each document ID to its shingle set, reusing the shingles function for consistency. Using combinations, it evaluates every unique pair, computing intersection over union for their shingle sets and storing both the pair and its score. The list pairs is then sorted by descending similarity and secondarily by the pair IDs for a deterministic tiebreak. Finally, It extracts the best match and prints the pair and rounded score. This ranking step identifies which items most deserve deduplication checks or manual review. Next, we demonstrate how a single parameter shifts sensitivity. This snippet tunes shingle size to adjust sensitivity and recomputes similarity for A and B. The function pairSim builds shingle sets for all documents using a passed K, and then returns the Jaccard score specifically for the pair of interest. With K set to 2, more short sequences match across the texts, so overlap rises compared to 3-word shingles. This change often pulls genuinely similar pages closer together without requiring exact longer phrases. Increasing K reduces matches and can suppress false positives. Decreasing K raises matches and can surface near duplicates earlier at the cost of more candidates to inspect. The printed score shows the sensitivity gain from shorter shingles. Finally, we convert similarity into a usable filter for an index. This example implements a tiny near duplicate filter using a similarity threshold. The function dedup first builds 2-word shingle sets for each document, then scans documents in sorted ID order, so results are stable. For each new document, it searches the already kept set and uses Jaccard to find the first item whose similarity meets or exceeds T. If found, the document is flagged as a duplicate of that earlier item. Otherwise, it is added to keep. The function returns the kept list and a mapping of duplicates to their source, lowering T or K flags more near duplicates. Raising them is stricter. The printed lists show what will be indexed versus removed. In a real project, you would map this to your ingestion pipeline by running the dedup step before indexing. Keep the detection in memory for small batches, or use a blocking key to limit pair comparisons for larger datasets. The toy settings translate directly. Experiment with K as shingle length and T as the acceptance threshold on a validation set of known duplicates. Recap what it is: a plain pipeline that tokenizes, builds shingles, computes Jaccard overlap, and ranks or filters by a threshold. When to use it: when you need fast, interpretable near-duplicate signals without embeddings or heavy infrastructure. One caveat: exact phrase matching misses paraphrases and tiny edits. So tune K and T and expect false negatives or extra candidates. Next step: tune shingle size K and the threshold T on a held-out set and measure precision and recall as you vary them. Then rerun on a larger corpus to set production defaults. If short, practical IR helps, subscribe and watch the IR videos.